Alright guys, welcome to this page of the notes. What we're going to do here before we take a look at an example problem is talk about the three possible options. Now the first one we have already seen, the middle one we've already seen a couple of times, and that's where you get two real solutions, right? We have the three example problems we've done so far. We've graphed our quadratics. They've either opened up or opened down and have crossed the x-axis in two spots. And so we have wound up with two roots, right? Two solutions. But there are a couple other possibilities that we want to talk about before we actually get to take a look at them. The first one's going to be this. What is going to happen is your parabola is actually going to have a vertex that is right on the x-axis. My vertex sits on the x-axis, which means instead of having two solutions, right, instead of crossing the x-axis twice, I will only touch the x-axis in one spot, which means I will only have one real solution, right? Because my vertex is on the x-axis, I will wind up with a 0 in my y column right at my vertex, right? That'll be the only 0 in my y column, and so it'll represent my solution. My parabola has a vertex right on the x-axis. And then the other possibility is that my parabola doesn't cross the x-axis, in which case you would have no real solutions. And let me just give you a little taste of what is to come, or give you a sneak peek at what's to come. No real solutions is kind of a hint at there are actually still solutions. They're just not real. They're actually imaginary. This is going to happen for us in section 4 of this chapter. We will get to imaginary and complex numbers and dealing with or talking about how you deal with those imaginary roots or imaginary solutions. You're not going to get real solutions because you don't actually cross the x-axis. Instead, you're going to wind up with imaginary solutions. So those are your three options. You will either have two real roots, which we've looked at a couple of examples. You'll have one real solution, one root when the vertex is on the x-axis, and you'll have no real solutions because your parabola doesn't cross the x-axis. Instead, you'll have imaginary, and like I said, we'll get to those in section 4. So let's just jump right into this and try one of these example problems here I've got for you on the next page of the notes, which is this one. Now, it's going to work exactly the same way as the ones we have done so far. I need to set up an XY table. In order to set up the XY table, I need to know the axis of symmetry, because that's going to be the very first value of x I plug into my table, and I'll go in either direction from there. But before I can find my axis of symmetry, I need my quadratic to be in standard form. And it isn't. So let's go ahead and do a little bit of rearranging. Remember, standard form is ax squared plus bx plus c is equal to 0. So I need to take these guys over here and move them to the left-hand side of the equal sign. Here's what I would wind up with if I did that. I will add 6x, I will subtract 23, and then we'll go about combining like terms. So here we go. 14 minus x squared plus 6x minus 23 is all equal to 0. We'll go ahead and combine like terms, which would be the 14 and the minus 23, which should get you a negative 9. So minus x squared plus 6x minus 9 is equal to 0, and that is now in the ax squared plus bx plus c. I've got it in standard form, right? It's all equal to 0. My a, my b, and my c are all integers. Awesome. Now we need to find the axis of symmetry. Okay, well, the axis of symmetry is at x equals negative b over 2a. So let's go ahead and find that. Well, my b is a 6. Okay, so I'd have a negative times a positive 6, which would be a minus 6. My a is a negative 1, which would give me a negative 2. Negative 6 divided by a negative 2 would be a positive 3. Let's go ahead and set up our table. I'm going to start my table with a positive 3, and we'll go 3, 2, 1, 0, negative 1, negative 2. That should be plenty of spots, which means I'm going to then go 4, 5, 6, and 7. Should be plenty of spots in that direction. Now let's go ahead and see what happens here. I plug a 3, because this was my axis of symmetry. I go ahead and plug a 3 into my quadratic equation. I will have a 3 squared, which would be 9, which I'll then need to make negative, so a minus 9. Minus 9 and minus 9 would be a negative 18. 3 times 6 would be a positive 12. So 12 minus 18, I'm sorry. Sorry. 6 times 3 would be 18. 18, so what we wind up with is 6 times 3, which would be a positive 18. Minus 9 and minus 9 is a negative 18. Mental math. And a negative 18 plus 18 is actually 0. Okay, this represents my axis of symmetry, right? My vertex. But please notice that the y value is 0, which means it's also my x-intercept. All right, let's keep going. I think going this direction will be a little easier. 2 squared is 4. I then multiply it by a negative to make it a negative 4. Negative 4 and a negative 9 would give me minus 13. 2 times 6 would be 12. Positive 12 minus 14 should be a negative 1. Plug in a 1. 1 squared would be 1 times a negative would be a negative 1. Negative 1 and a negative 9 would be a minus 10. Plug in a 1. 1 and 6 would be 6. And so we wind up with 6 minus 10, which would be a negative 4. Okay, plug in a 0. 0 and 0, those terms are all going to drop out. I'm left with a minus 9. Actually, let's go ahead and box in that one, because whenever the x value is 0, I know that I have a y-intercept. And I think this next one's going to be too big. I don't think it's going to fit, but let's do it anyway. I plug in a negative 1. Negative 1 squared is going to be a positive 1, but then I multiply it by the negative. So again, it'll be a negative 1. A negative 1 and a negative 9 would be a minus 10. Negative 1 times 6 would be a negative 6, and wind up at negative 16, which isn't going to fit on my graph. So I'm actually going to leave that one out, leave those ones out. Let's go ahead and graph the rest of them. 3, 0. 1, 2, 3, 0. Oh, and there is not only my vertex, but also my y-intercept. So I have one real solution. Let's see here. 2, negative 1. 2, negative 1, and 3, negative 1. 1, negative 4. 1, 2, 3, 4, and 5, negative 4, and then 0 minus 9, and 6 minus 9. And go ahead and draw your parabola. Feel free to draw your axis of symmetry as well if you would like. Again, I didn't ask you for it, but it might help you out if you want to. It doesn't certainly hurt to practice. And again, the things I'm going to ask you for, well, I'm going to ask you for the roots. In this case, you have one root, one solution, and it's at 3, 0. I'm going to ask you for the vertex, which also happens to be 3, 0. Your vertex and your x-intercept are the same point. And I'll ask you for the y-intercept, which is at 0 minus 9. Great, guys. That takes care of this problem. Hopefully that makes good sense. Again, everything you need comes from the table, which you'll get by first finding your axis of symmetry, and your axis of symmetry will come from putting your quadratic in standard form. Head on over to the next page of the notes and we'll try a few more of these. I'll meet you guys there.